Hello everyone. Today we will discuss regarding the hemoglobin synthesis. In the previous video we discussed regarding the structure of the hemoglobin molecule, that it contains 2 alpha and 2 beta chains, and in each globin chain there will be the heme group. Heme group contain protoporphyrin ring 9, and in the center of this ring there will be the one iron molecule attached, and it will form the heme molecule. So you can refer the previous video for the structure of the hemoglobin molecule. Structure function relationship of the hemoglobin. Oxygen binding curve की बात करें तो its shape is sigmoid shape, and this type of binding is said to be cooperative. Cooperative means positive cooperativity इसको बोलेंगे, because binding of oxygen to one heme increases the binding of the oxygen to the other heme molecule. जैसे कि इसमें 4 ग्लोबिन चेन है, अगर 4 में से किसी भी एक मॉलिक्यूल पे ऑक्सीजन बाइंड हो जाती है, then it will increase the affinity of the oxygen binding at the other heme molecules. Thus the affinity of the Hb for the last oxygen is about 100 times. That is greater than the binding of the first oxygen to the hemoglobin. अब यहीं पे बताया कि कितनी ज़्यादा ये affinity increase हो रही है. तो this type of affinity is called as the positive cooperativity. This effect is also called as the heme-heme interaction. Then the agents that affect the binding of the hemoglobin. First one is the hydrogen ion. When hydrogen ion are increased, then there will be the decrease in the pH. Decrease means कि जो condition होगी that will be acidic. So hemoglobin will release the oxygen more easily. In this way, it will decrease the hemoglobin affinity for the oxygen, and this is called as the Bohr effect. And when the carbon dioxide binds to the hemoglobin, it will form the carboxyhemoglobin, and 2,3-bisphosphoglycerate will also cause the unloading of the oxygen molecule. So all these affect the binding of the oxygen molecule, and they will decrease the hemoglobin affinity for the synthesis of the hemoglobin. Heme is synthesized in the most of the cells of the body, and liver is the main source of the heme, because as mature RBC are lack mitochondria, so they cannot synthesize the hemoglobin molecule. तो most commonly अगर बात करें तो immature erythrocytes में hemoglobin की formation होती है, which are present in bone marrow. Immature RBCs are fully functional cells. Once the cells has accumulated its full lifetime supply of the hemoglobin, it prepares to enter into the bloodstream, and they become the reticulocytes. So it will occur both in the cytosol and the mitochondria. Cytosols में cytoplasm. तो hemoglobin की formation से कुछ उसकी जो processes हैं, they will occur in the cytoplasm, and half of the processes will occur in the mitochondria of the liver and the immature erythrocytes in the bone marrow. जो hemoglobin synthesis है, ये एक highly coordinated process है, and it will occur within the immature RBCs in the bone marrow. और it is also a compartmentalized process. Compartmentalized means कि कुछ processes कहाँ हो रही है, mitochondria में हो रही है, और half of the processes will occur in the cytoplasm. So this is the cytoplasm. There are multiple steps involved in the heme synthesis, and 8 enzymes complete this process. 4 in the mitochondria, 4 enzymes do this process in the mitochondria, and 4 in the cytoplasm. So first of all, succinyl coenzyme A condenses with the amino acid glycine to form the delta aminolevulinic acid. In the presence of this process occur in the presence of enzyme aminolevulinic acid synthetase. So here there will also requirement of vitamin D as a cofactor to do this process, and this ALA will shift into the cytoplasm of the cell. Here 2 molecule of ALA condenses into the porphobilinogen in the presence of enzyme, that is ALA dehydratase. Then condensation of the four molecules of the porphobilinogen occur, and it will lead to the formation of the porphyrin ring. Here, this process will occur in the presence of enzyme uroporphyrinogen 1 synthetase. So it will form the hydroxymethylbilane. Here, it will lead to the formation of uroporphyrinogen 3 in the presence of enzyme uroporphyrinogen 3 co-synthetase. It acts as a cofactor, and here uroporphyrinogen 3 lead to the formation of coproporphyrinogen 3, and this coproporphyrinogen 3 will enter into the mitochondria of the cell, and here it will lead to the formation of protoporphyrinogen 9 in the presence of enzyme coproporphyrinogen oxidase. Then this protoporphyrinogen 9 is converted into the protoporphyrin 9 in the presence of enzyme protoporphyrinogen oxidase. And then enzyme ferrochelitase insert the ferrous iron, that is Fe2 positive, into the center of the ring to form the functional hemoglobin molecule. So heme contain the protoporphyrin ring 9 and also the Fe2 positive molecule, then it is called as the heme molecule. Then next is the regulation of the heme synthesis. The heme synthesis is regulated mainly by the liver and through the erythrocytes. So the first step in the heme biosynthesis is catalyzed by the enzyme aminolevulinic acid synthetase, and this enzyme is a regulatory enzyme. रेगुलेटरी मीन्स कि इसके लेवल को रेगुलेट किया जा सकता है. तो ये जो एंजाइम है, it is regulated by the three mechanism. First one is the feedback inhibition. Feedback inhibition का मतलब हुआ कि whenever there will be the increase in the heme molecules, then this will directly inhibit the ALA synthetase enzyme. The next is the repression of the ALA synthetase. सो रिप्रेशन मतलब कि इसकी फॉर्मेशन क्या है, सुप्रेस्ड रहेगी. देन नेक्स्ट इज द इनहिबिशन ऑफ ट्रांसपोर्ट ऑफ ALA सिंथेटेज फ्रॉम द साइटोसोल टू द माइटोकॉन्ड्रिया. सो ये जो एंजाइम है ALA सिंथेटेज, ये मेनली इसकी फॉर्मेशन साइटोप्लाज्म में होती है, एंड देन इट विल एंटर इनटू द माइटोकॉन्ड्रिया. सो जो हीम का लेवल जब इंक्रीज होगा, इट इनहिबिट द ट्रांसपोर्ट ऑफ ALA सिंथेटेज फ्रॉम साइटोसोल इनटू द माइटोकॉन्ड्रिया. साइटोसोल का मतलब है साइटोप्लाज्म, जो इंट्रासेलुलर फ्लूइड होता है सेल में, उसको साइटोसोल बोलते हैं. तो दैट विल ऑल्सो इनहिबिट द ट्रांसपोर्ट ऑफ दिस एंजाइम. The next is the regulation in the erythrocyte cells. Erythrocytes में ALA synthetase का कोई मैकेनिज्म नहीं है कंट्रोल करने का, बट erythrocyte में जो मेन एंजाइम है दैट इज द यूरोपोर्फाइरिनोजन सिंथेटेज और फेरोचेलिटेज. तो ये जो दो एंजाइम है, दे कैन बी रेगुलेटेड बाय द erythrocyte cells. By regulation of these enzyme, the heme formation can be controlled. Further, the cellular uptake of iron is also interfere with its synthesis. So heme and globin synthesis is in right proportion for the hemoglobin. Then next is the some important points regarding the hemoglobin synthesis. Hemoglobin synthesis occur in the rat bone marrow. मेनली वहाँ पे क्या होते हैं, इमेच्योर इरिथ्रोसाइट्स होते हैं जिसमें माइटोकॉन्ड्रिया प्रेजेंट होगा. तो हीम फॉर्मेशन मेनली हो कहाँ रही है, माइटोकॉन्ड्रिया और द साइटोसोल. Then hemoglobin consists of heme and the globin. Heme is a non-protein part and globin is a protein part. Then heme contain iron mainly in the form of Fe2 positive ferrous form में. Globin is a protein made up of amino acid and heme synthesis occur in the mitochondria and the cytoplasm. तो दोनों में इसकी फॉर्मेशन होती है. इसमें टोटल 8 स्टेप्स 8 एंजाइम यूज़ होते हैं, जिसमें से 4 एंजाइम माइटोकॉन्ड्रिया में फंक्शन करेंगे और 4 एंजाइम साइटोप्लाज्म में फंक्शनल होंगे. देन ग्लोबिन सिंथेसिस अक्कर इन द राइबोसोम्स. Main precursor are the glycine and the succinyl coenzyme A. So these are the two main molecule which will form the ALA molecule. That is aminolevulinic acid की ये formation करते हैं. देन ALA सिंथेटेज इज अ रेट लिमिटिंग एंजाइम, जो मैंने आपको पहले भी बताया कि क्या इसके लेवल को रेगुलेट किया जा सकता है, और ये एक रेट लिमिटिंग एंजाइम है कि जितने जल्दी ग्लाइसिन प्लस सक्सिनाइल को एंजाइम ए से ALA की फॉर्मेशन होगी उतने ही जल्दी ये साइकिल कंप्लीट होगा। तो इट इज़ अ रेट लिमिटिंग एंजाइम कि जितनी जल्दी ये एक्ट करेगा उतनी जल्दी हीमोग्लोबिन की फॉर्मेशन होगी। Then vitamin required for heme synthesis is mainly vitamin B6. Iron combines with protoporphyrin 9 to form the heme molecule. So ये जो protoporphyrin 9 ring है, it will combine with Fe2 positive and it combine at the center of this ring. तो जो iron है, it will combine in the center of this ring and it will form the hemoglobin molecule. एंजाइम एडिंग आयरन इज फेरोचैलिटेज, जो लास्ट स्टेप था सिंथेसिस का, वहाँ फेरोचैलिटेज एंजाइम Fe2 पॉजिटिव आयरन को अटैच करता है, दैट विल फॉर्म द हीम मॉलिक्यूल. So this is all about the synthesis of the hemoglobin molecule, and we also discuss some important points regarding this. Thank you.